All right, this is review for your test 2-4, which is on January 10th. Again, your review sheet, it was due on Wednesday. The colored corrections are due on the day of the test, which is Friday. So for number 1 and 2, you're simplifying radical expressions. So for number 1, this is a square root. So we have to see what's the largest perfect square that goes into 243. So that's going to be the square root of 81 times the square root of 3. The square root of 81 is 9. You're left with the square root of 3. Leave some room for your letters. Again, it's a square root, so this is a 2. 2 goes into 8 4 times. No remainder. 2 goes into 13 6 times with the remainder of 1. And 2 goes into 5 2 times with the remainder of 1. You don't have to put the 1 there, but that is your answer. If you put it there or don't, it doesn't really matter. For number 2, the only difference is now this is a cube root. You're going to do the letters the same, the variables the same, but now you're looking for the largest perfect cube that goes into 162. So the largest perfect cube that goes into 162 is 27, and it's 27 times 6. The cube root of 27 is 3. You are left with the cube root of 6. And then for your letters, for your variables, 3 goes into 9 3 times, no remainder, which means that x to the 9th is a perfect cube. 3 goes into 13 4 times with the remainder of 1. And 3 does not go into 2 at all, so z squared goes inside of your radical. And that's it for number 2. For numbers 3 and 4, so this was that difficult stuff that we did right before the holiday break. So we're going to first put this into radical form. So we're going to make this the cube root of 27 x to the 10th y to the negative 6th. And then once we do that, we're going to square it. Okay, I try to go smaller before we get larger, before we square it. So I'm going to take the cube root first. So the cube root of 27, that's a perfect cube. That's 3. And then for the variables, 3 goes into 10 3 times with the remainder of 1. And then 3 goes into negative 6, negative 2 times. And now we have to raise everything to the second power. So 3 squared gives me 9. X to the 6th, power you multiply, y to the negative 4th, and then you have the cube root of x squared. X to the second power, you get x squared. So now the only thing left to do, because this radical here you cannot clean up at all. The cube root of x squared, you can't do anything with it. So now I have to see about this negative exponent right here. So all I'm going to do now is move this negative exponent to the denominator. So my final answer, I'll put over here, is 9x to the 6th cube root of x squared divided by y to the 4th. Okay. For number 4, same idea. I'm going to put it into radical form first. These are hard. So if you're struggling with this, don't think that you are alone. So this is the square root of 12, x to the negative 16th, y to the negative 10th, and then raised to the 5th power. So again, I'm going to do the square root first. So unfortunately, unlike the 27 a second ago, 12 is not a perfect square, but 12 is 4 times 3. So this is 2 square root 3. And then we have 2 goes into negative 16, negative 8 times. 2 goes into negative 10, negative 5 times. And I have to raise this to the 5th power. So everything gets raised to the 5th, including the 3 that's inside the radical. 2 to the 5th is 32. And then we have x to the negative 40th, y to the negative 25th, square root of 243. All right, so if you want, you can get rid of those negative exponents first, or this has to be cleaned up. Okay, so you could do either one first. It doesn't matter. So I'm going to do the negative exponents first because I think you guys, it'll look a little bit better for you. So 32 square root of 243 divided by x to the 40th, y to the 25th. The square root of 243, that is 81 times 3. And the square root of 81 is 9. So I have 32 times 9 square root 3. So it's going to end up being 288 square root of 3 divided by x to the 40th, y to the 25th. Again, it's very tricky, some of these. Okay, number 5, we have these fractional exponents, right? We like doing these in class. So first I'm going to subtract the 15. And that'll give me 7 times 2x raised to the 3/4 power is equal to 56. And then I divide by the 7, so 2x raised to the 3/4 power is equal to 8. Now, to get rid of the 3/4 power, I raise both sides to the 4/3. The denominator here is a 3. So what I'm really doing on this side, this is going to cancel out, so I get 2x equals, on this side, on the right side, I'm really doing the cube root of 8 to the 4th power. The cube root of 8 is 2, not plus and minus 2 because it's an odd root. The cube root of 8 is 2, and then 2 to the 4th is 16. So if you just type that into the calculator, you end up getting 16. And then you divide both sides by 2, and you get x is equal to 8. Plug that back into the original equation. It does work, so x equals 8 is your only answer for number 5. For number 6, same idea. So first I'm going to rewrite this as 3 times x minus 1 raised to the 2/3 power plus 9 equals 21. I'm going to subtract the 9 and divide by 3. So now I'm here, after I subtract the 9 and divide by 3, I end up with 4. So now I have to get rid of that 4/3 power, so the 2/3 power, so I raise it to the 3/2. I raise it to the 3/2. This cancels out. I get x minus 1 equals, I am doing the square root of 4 to the 3rd power. Okay, so because I'm doing the square root, I have that plus and minus thing. So the square root of 4 is 2, and 2 to the 3rd gives me 8. On the other hand, the square root of 4 could also be -2, and -2 cubed is -8. So I solve these equations. This gives me x equals 9. This one gives me x equals -7. Plug them both back into your calculator. They do both, in fact, work out. You do have to check these. And last one, number 7. I'm going to add the 1 to the other side. This is really x plus 43 to the 1/2 power. I know you see it's a square root, so I know you're going to know that you just have to square it. So you don't really have to write that. You can keep it inside of the radical if you would like. And then you raise both sides to the 2nd, or 2/1 if you want. This cancels. I get x plus 43. Now the difference with number 7 is you cannot type this into the calculator. For this you have to do x plus 1 times x plus 1, which gives me x squared plus 2x plus 1. This is a quadratic equation now, so I'm going to subtract the x and subtract the 43. This cancels over here. I get 0 equals x squared plus x minus 42. I do master product. My two numbers are going to be 7x and -6x. This is x times x plus 7 minus 6 times x plus 7. So x plus 7 times x minus 6 equals 0, which gives me my two possible answers, x equals -7, x equals +6. I plug them both back into the calculator, and I see that x equals -7 does not work. However, x equals 6 does. All right, 8 through 10, this is what we were doing on Monday and Tuesday this week. So for number 8, you need a common base between the two of them. So 4 and 16, I can rewrite this 16 as 4 to the 2nd power raised to the x minus 2. So the only thing that I changed is I turn this 16 into 4 squared. And now I'm going to do my power to power. I multiply. So 4 to the negative second is equal to 4 raised to the 2x minus 4. Once the bases are the same, the exponents have to be the same. So negative 2 equals 2x minus 4. I end up getting that x is equal to 1 from this equation. You plug it back in to check it, and it does in fact work. For number 9, so I have, if you want to, you could rewrite this as 216 to the negative first power. You don't have to, but between 36 and 216, that common base is going to be a 6. So this is 6 to the second power raised to the 2x minus 15. And then 1 over 216 is 6 to the negative third power because it is in the denominator. It was flipped, so that's why it's negative third raised to the 8 minus 4x. So this is now 6 raised to the 4x minus 30 equals 6 raised to the negative 24 plus 12x. And that is now the equation that I'm going to solve. 4x minus 30 equals negative 24 plus 12x. Which I go to solve this, I get negative 8x is equal to 6. X is equal to negative 3 over 4. If you want to write negative 0.75, that's fine. You plug it back into the original question, and it does in fact work. So negative 3/4 is your answer. And then the last one of these is number 10. So for number 10, between 1/5 and 125, your common base is going to be a 5. So I'm going to rewrite 1/5 as 5 to the negative first, raised to the negative 2x squared minus 4. And the other one is going to be 5 to the positive third, because it's not that fraction, raised to the 10x minus 32. So now this is going to be 5 raised to the positive 2x squared plus 4 equals 5 raised to the 30x minus 96. So now my equation is 2x squared plus 4 equals 30x minus 96. I set it equal to 0 plus 100 equals 0. If you want to divide everything by 2, you can, so it turns into this. Two numbers that multiply to be 50, add to be negative 15, are going to be negative 10 and negative 5. Split it down the middle. Over here, x minus 10. On the other side, negative 5 times x minus 10 equals 0. So that's x minus 10 times x minus 5 equals 0. You get x is equal to 10 and x is equal to 5. You can check x equals 5 and it works. X equals 10, the number is too big, so it tells you that there's an overflow error, but it also works. Okay, and then the last one, not the last one, number 11 is the parabola. So the focus is 4, 0. 1, 2, 3, 4 is right here. And the directrix is y equals negative 6 is right here. Okay, so parabola x minus h squared equals 4 times p times y minus k. H comma k is your vertex. It's directly in the middle of these two. So this is 6 apart, so 3 is in the middle. So the vertex is going to be 4, negative 3. This is going to be concave up because it has to hug your focus. And then you are going up 3, which means that your p-value is 3. So your equation is x minus 4 squared equals 12y plus 3. For number 12, describe the transformations performed to acquire the image function. So this is just, do you know your rules? So here, plus 5 tells me that I'm going left 5, and minus 3 is down 3. That's all. For number 13, the inverse. Inverse, you switch the x and the y, and then you solve for y. So first I'm going to add the 5. X plus 5 equals the square root of y over 8. I multiply both sides by 8. And I get 8x plus 40 equals the square root of y, and then I square this. Now the question doesn't want it it doesn't say polynomial form, so you can literally just leave it like this. This cancels this out. So I'm going to have 8x plus 40 squared. I'm not going to multiply it out. You can if you want, but, and then I'm going to write it in the correct notation. For number 14, state the intervals of increasing and decreasing. So first you're going to plug that equation into your calculator. After you plug that into your calculator, I suggest you draw a little sketch of it, just so you know what you're working with. This looks something like this. And before you can do the increasing and decreasing interval, you need to know the mins and the maxes of your graph, because that's where it changes direction. That's where it goes from increasing to decreasing or decreasing to increasing. So up here, if you do second trace, you choose number 4. You have to do the left bound, the right bound thing. We really only care about the x value. This x value is negative 2.897. I told you guys in class to round to the nearest thousandth. So this is the nearest thousandth. And then I do the same thing, but instead of second trace maximum for this one, I'm going to do second trace minimum. And that gives me 0.230. Now with increasing and decreasing, I told you that you should draw a number line where this is negative infinity, this is positive infinity, and then you put those intervals on here. So negative 2.897 and then 0.230. So from negative infinity until this maximum, the 2.987, I am increasing, and then I change direction and I am going down, so then I'm decreasing, and then I'm going back up again, increasing. This is not enough though for your intervals, because it wants it in the interval notation. So for increasing, remember, you're not going to use any brackets on these. You have negative infinity until negative 2.897, and then you start to decrease from negative 2.897 until 0.230, and then you start to increase again from 0.230 up until positive infinity. If you want to put a u in the middle, you can. Probably would see it with the u if it's multiple choice, but not a big deal. 15, quadratic linear system of equations. So we have, I told you to change this number in class. I think this was a 13, but now it's going to be a 14. Over here, I need to put this equation the way that I want. So I'm going to add the y. So y plus 13 equals 2x. Y equals 2x minus 13. So that now I can take what y is equal to and plug it in up here. So now I have 2x minus 13 equals negative 3x squared minus 14x minus 29. When I set this equal to 0, I should get 3x squared plus 14x plus 16 equals 0. I need two numbers that multiply to be 48, but add to be 14. Those two numbers are going to be 6 and 8. So 3x squared plus 6x plus 8x plus 16 equals 0. When I split this down the middle, 3x, x plus 2, 4 times x plus 2. So this is x plus 2 times 3x plus 4, which gives me my 2x values of negative 2 and negative 4 over 3. The question, though, wants the answer to the system, so I have to then find the y values. So if x equals negative 2, y is equal to, from right here, y is equal to 2x minus 13, which gives me negative 17. So this one is negative 2, comma, negative 17. The other one, if x is equal to negative 4 over 3, y is equal to 2 times negative 4 over 3 minus 13, which gives me negative 55 over 3, not 13, over 3. So then this coordinate is negative 4 thirds, comma, negative 55 thirds. And then the last one is the system. All right, so I'm going to do elimination. Get rid of this. Elimination on equations 1 and equations 2. Then I'm going to do eliminations on equation 1 and equation 3. and then I'll do it again, and then I'll get 1 point, and then I just kind of back it up after that. Make sure you know how to type this into the calculator, though. You would use second matrix to type it in. You would go to edit. You put the whole thing in, and then you quit, so you have to leave the screen. And then you do second matrix again, go over to math, and it's RREF, reduced row echelon form. And then you have to select matrix A, okay? So again, if it doesn't say algebraically, you can just type it right into the calculator. So for equations 1 and equations 2, I'm going to multiply the top equation by a -4. That way I'm going to cancel out the z's. So -4x plus 24y plus 4z equals 32. And then for the bottom, that's going to stay the same. The whole point is that these cancel out. So this is now 3x plus 33y equals 24. That's equation A. Now I'm going to do the same thing on 1 and 3. So for 1 and 3, I have to eliminate z again. So I'm going to multiply the top equation only by 2 because I need the signs to be opposite. So the top is now 2x minus 12y minus 2z equals -16. The bottom stays the same, 2x plus y plus 2z equals -7. You could have also canceled something else out if you wanted to cancel out the x or the y, it doesn't matter. So this is now 4x minus 11y equals -23. And that's equation B. So to do elimination on A and B, I'm going to eliminate the y value. So to eliminate the y value, I'm going to just multiply this bottom equation by 3. 3x plus 33y equals 24. And then when I multiply this bottom one by 3, this is 12. This should be an x. Sorry. 12x minus 33y equals -23 times 3 is -69. I add down, these cancel. This gives me 15x equals 24 minus 69 is -45. So x is equal to -3. Once I get one of them, I then plug it all back in. Okay, so if I do this for the equation A, 3 times -3 plus 33y equals 24. 33y would be equal to 33. Oh, duh. And y is equal to 1. And then finally I plug it into I'll plug it into equation 1. We have x minus 6 times y minus z equals -8. This would be -z equals -8 plus 3 plus 6 is 1, so z is equal to -1. And then I write it as -3, comma 1, comma -1. Okay? If you have any questions, extra help is after school on Thursday. Okay? Have a good day.